maximum galvanometer current, or maximum current, we'll call this one. So if you send 10 milliampere, so the pointer will be at 10 milliampere. If you send 5 milliampere, the pointer will be at 5 milliampere. If you send 1 milliampere, 1 milliampere. If you send 20 milliampere, the pointer cannot go beyond. It will be there at 10 milliampere. And it may get damaged. Any current, if you send more than that IG, then the galvanometer will get damaged here. So how to search IG value? So looking at from the scale. So what is the maximum permitted value of that particular current to galvanometer? In the scale, it will be mentioned. The maximum is what? 10 milliampere. So now what will happen? We can put IG equal to 10 milliampere. Can we measure the voltage? So what is VG equal to? Let's assume usually galvanometer will pick up 100 ohm the resistance. So what is VG equal to? IG into G. So this will be 10 into 10 to the power of minus 3 into 100. 1 volt. So what is the maximum permitted voltage? What is the maximum voltage I can measure across galvanometer? Is saying that 1 volt. This is called like a galvanometer voltage. So maximum voltage that maximum voltage a galvanometer can measure. This galvanometer. If you apply potential difference 2 volt, then the pointer will be at 10 milliampere and it cannot deflect further. So therefore, this will put the limit on the maximum current a galvanometer can measure. No? And what about this? This VG will put the limit on maximum voltage it can measure. The maximum voltage it can measure. So therefore, if I want to use this galvanometer to measure higher currents, if I want to use to measure this galvanometer, if I want to use to measure this galvanometer for higher voltages, I can't use, no. So what is the limitation for this galvanometer? I can measure any current 0 to 10 milliampere. What is the maximum voltage I can measure? 1 volt. Now the same galvanometer, how I can use this to measure higher currents, or how the galvanometer I can use to measure the higher voltages is what the topic will be. A device which is specifically used to measure current, range of current. It's called as the ammeter. So first we'll start with the ammeter, a device used to measure a range of currents. It's called as the ammeter, that one. So how to convert, means now what is available? Only galvanometer is available for us. The galvanometer only what should be modified to read larger current. But again, if you send current to galvanometer more than 10 milliampere, what happens? The galvanometer will get damaged. So I'll put here, if current through galvanometer is greater than IG, the galvanometer damaged in the sense the pointer itself what happen again will not return back to 0. The inside the galvanometer, the spring will be there, that will get damaged here. The total equipment will get damaged here. So that's why, so this is some precaution we have to take it. So the current through galvanometer should never cross, should never even touch this IG. Should be slightly less than IG, 10 milliampere, 9.9 milliampere. Okay, fine. This is a precaution what we have to take whenever we are using the galvanometer. Okay, now the same galvanometer, I'm going to convert that into ammeter. So for that, there is a galvanometer which will have galvanometer resistance, and there is a scale 0, 5, 10 milliampere. What is the value of this 100 ohm? Now I'm going to bring a low resistance in parallel. I'll call this as shunt. So what do you mean by, so what is the value of Ig? Let me indicate all that one. So Ig, how much it is? 10 milliampere. A low resistance connected in parallel is called as a shunt, and there's a current which I want to measure. So what is the range of current I want to measure? I want to measure a current of, say, like some higher order. Then I can take help of this condition. So what is this? S is called as a low resistance. What do you mean by shunt? First, a low resistance connected in parallel. A low resistance connected in parallel is called as a shunt. That is the one basic way of defining the shunt. So now they did not call even shunt resistance. I think in exam you have to be careful. They just say a shunt is connected. Sir, he didn't say it's a ammeter, voltmeter, resistor, capacitor. A low resistance connected in parallel is called a shunt. This, instead of calling low resistance connected in parallel, they just use word shunt. A shunt is connected means it should flash for you this much here. There's a convention. Now let the current flow to the galvanometer. Let it be Ig. So what is the remaining current? Flows will be I max minus Ig. So give polarity plus minus, and the same current Ig will come. I max minus Ig minus Ig. So that equal to I max here. So when you apply that maximum current, a current which has to be measured. So what is this? What is this I max? A current to be measured. What is our goal? We have to measure this Imax. For that, I'm connecting a low resistance in parallel with the galvanometer. And this is the galvanometer. Okay, how they are? So as good as it is like a two parallel circuits, no? Instead of thinking something very big, there are two parallel circuits are there, and we are sending current Imax. Then a current will branch. The remaining Imax minus Ig, and the same current it has to leave. This is G. So this is equivalent circuit. In place of galvanometer, replace with a galvanometer resistance. How they're parallel. So when they're parallel, the drop should be equal. So here I max minus Ig into S should be equal to Ig into G. So what is the value of shunt to be connected? Ig into G by I max minus Ig. So what is Imax? The range of current which you want to measure. Suppose what was the maximum current in a galvanometer? I can measure 10 milliampere. So I want to, let's go for this one. So first the range is Imax equal to 100 milliamperes. So what is the galvanometer? No, not maximum current. Shunt, it's a just definition, nothing to do. So Imax equal to how much? Is equal to 100 milliampere. Then what should be the value of the shunt that should be connected here? No? So this should be equal to, it should be equal to 100 milliampere, 100 into 10 to power of on the numerator, 10 into 10 to power of minus 3, 100, 100 into 10 to power of minus 3, 10 into 10 to power of minus 3. So this should be 1000, 1000 divided by 90 will get it. So this will be 100 by 9. 11.11 ohm. So this will be the value of the resistance which I should connect here. So let's see that how do it will work out. How do it will work out? Really, sir, will it measure? So the same galvanometer. I didn't going to change the galvanometer. So what was the range? 0, 5, 10 milliampere. Then what I connected? I connected a shunt value of how much? Then how much of current? Let me pass the current equal to say like a 50 milliampere. Then how much will flow? 5 milliampere will flow here because the value of shunt resistance we have so chosen that 5 milliampere will flow here. Remaining 45 milliampere will flow. Current divider formula, you know it, and the same 5 milliampere will come, and this will be 50 milliampere. Then if a 5 milliampere flows, where the pointer? Pointer will be at 5 milliampere. This will be the pointer. This will be the position of pointer. Now I want to measure this current, no? So what is the current? 50 milliampere. So therefore I'll go for one more scale. Here I'm going to put one more scale, or I'll close this galvanometer scale. So what should be this scale? This should be 100 milliampere, 50 milliampere, 0 milliampere. If I send 50 milliampere, the pointer open here, how much of current will flow through the galvanometer? 5 milliampere only, because the value of shunt is so chosen that 45 milliampere will pass through the shunt, only 5 milliampere will pass through it. If a 5 milliampere flow, the pointer will come. I'll close this scale. I'll close this scale. If I close this scale, just get only the green color scale. So where the pointer is 50 milliampere. So what this galvanometer is reading now? It is reading 50 milliampere. Okay, so there are two scales are there. So what is this? This will be a ammeter scale here to call. Now which scale we should look at? Ammeter scale. So therefore in the lab what I do, I'll close this the galvanometer scale. I'm going to close this galvanometer scale. If I close that, then I'll be only what will be visible? Only ammeter scale. If I send 50 milliampere, pointer will be at 50 milliampere. If I send 10 milliampere, the similar diagram. There's a construction. Once see, like if you are able to understand this basic, the rest all numericals are very easy for you. Now, if I send, let's assume that I'm going to send here the 20 milliampere. Then how much here? 2 milliampere. The remaining 18 milliampere will flow. Now, why, sir? Why you are making the current to flow? By current divider formula, you check it. 0, 5, 10 milliampere. And here is what 2 will be there. The pointer now will be located at 2 milliampere. But what will happen? I should look for the ammeter scale. In the ammeter scale, how I should modify. Don't modify for 0 to 20. What was the scale design? The scale was designed. I think I'm writing very small font. You better magnify in your mobile. So this should be the value how much? 20 milliampere. So if you cover this galvanometer scale, then you look at only the green color scale, that one ammeter scale. Then if 20 milliampere flows here, when 20 milliampere flows here, how much here? Pointer will be 20 milliampere. When 50 milliampere, pointer will be at 50 milliampere. When 100 milliampere, 10 milliampere will flow here. Then the pointer will come 10 milliampere. Close this scale, then 100 milliampere it will indicate. So by just connecting a low resistance in parallel with the galvanometer, what we are doing, we are increasing the range of galvanometer. We are increasing the range of galvanometer. So therefore, now what is ammeter now? So what you should call ammeter? The ammeter means here a shunt with galvanometer will become ammeter. So altogether, a low resistance in parallel with galvanometer will be ammeter. So what is ammeter now? This total setup you have to call ammeter. Okay, fine. This will be. So now, what is ammeter now? So galvanometer in parallel with the shunt is called as ammeter. So now this particular what all current flowing. So will it encounter any effective resistance as galvanometer and the shunt in parallel? So what is the ammeter resistance? The ammeter resistance should be equal to GS by G plus S. So what you should call this? Ammeter resistance or internal resistance of an ammeter. Altogether, the device will offer some resistance to the external circuit. How much it is? GS by G plus S. That will call as ammeter resistance here. So they say like now I'll increase the range. So I max 100. No? So let me go for 1000 milliampere. 1000 milliampere means so it will become 1 ampere. Then what is the formula? Shunt is equal to Ig into G by I max minus Ig. So what is Ig value? 10 into 10 to the power of minus 3 into 100 by, this is 1000 into 10 to the power of minus 3. 1000 by 990. 100 by 99. This will be 1.01 ohm. I think so. As we increase the range, what is this Imax now? I should call range. So what is the values? Can it measure only 1000 or anything from 0 to 1000? Anything from 0 to 1000. If you send 500 milliampere, then current through galvanometer. I'm just there's a last diagram. So what is the value of shunt? We are should be connected now. 1.01 ohm. Again, there's a galvanometer scale. So now you have to modify this scale also. 0 to 1000 it should be. Or 1 ampere, better you call. 0.50. If I send 0.5 ampere, what actually happens here? 5 milliampere will flow here. 495 milliampere will flow here. So since 5 milliampere flows, so the pointer, or I'll put it 0.6. 600, 595. 594. So 6 milliampere. So how much of current I sent? Actually 0.6 ampere. So where the pointer will be, okay, got this one now. So this is what the ammeter scale. And the below one is what? The galvanometer scale. There's a mechanism of working. So it can, you don't think that it will measure only 1000. Anything from 0 to 1000 milliampere or 0 to 1 ampere, the ammeter will measure. So this was the galvanometer. So what galvanometer made up of? Shunt and what ammeter made up of? Shunt and galvanometer. So therefore, shall we put like this? As range increases, the value of shunt decreases. Shall we put this? This is the one basic rule you have to remember. Means as I go for 10 ampere, if I go for 10 ampere, then what is the value of the shunt required? The last one. So I is equal to how much? 10 ampere. 10 milliampere means it will become 10,000 milliampere. So the value of shunt required will be Ig by G by range into Ig. So this will be 10 into 10 to the power of minus 300, 10,000 milliampere minus 10 into 10 to the power of minus 3. So this will be 1000 by 9090. 100 by 99. So this will become less than 1 ohm. 100 divided by 999. 0.1. So what is the now? What is the problem we are going to encounter? Instead of 1.01, let's come for here. Instead of 1.01, if it is there 1.11 ohm, what will happen to the range? The range is going to change. So therefore, look at this one. Exactly how much I needed? I needed 0.1, 0.1000 ohm. So it is. So if value is this much, then only open the range will be available for 0 to 10 amperes. So now as I go for, as I increase the range, so as I increase the range of the ammeter, so what is the value of the shunt required will become very low value. No, manufacturing of shunt of such a low resistance, and that too with precise, exactly it should be 0.1. Then will open, it'll get converted to that particular range. Otherwise there'll be some error. So these are the some problems what I encounter for the low values of the shunt here. So this I'll overcome by some other method. I'll overcome by some other method here. So therefore, as the range increases, the shunt value, the shunt value decreases. There's a condition which you have to remember. For ammeter, at the range, shunt value decreases. And what is the effective internal resistance of ammeter? Galvanometer resistance and shunt resistance, how they are parallel, as seen by the current entering a junction. As seen by the current entering a junction. So therefore, the internal resistance of ammeter should be GS by G plus S. Okay, this is overall. So let's see that practically if I use it, what are the problems I'm going to encounter? Means here afterwards, we need to show in detail all galvanometer, everything. So there are two resistors are there. Let it be R1 2 ohm, R2 3 ohm. Let the EMF of this cell be 2 volt. Then on paper we'll calculate what is the current flowing will be E by R1 plus R2. This will be 2 by 2 plus 3, 2 by 5, 0.4 ampere. This is on paper, but how do I measure that current? Practically, I want to measure it. So I'll construct a circuit. I'll bring an ammeter into the picture. Now this ammeter, I'll show a symbol A like this. Just a very simple approach is there. So where all this ammeter. Ammeter means here after will show like this. There's an arrow, this one, and you write RA nearby. What do you mean by RA? The resistance of the ammeter. 2 volt, R1 is 2 ohm, here 1 resistor, R2 3 ohm. Let this internal resistance of this ammeter be 1 ohm, because definitely I can never get an ammeter with zero internal resistance. So why it is not possible? Look at this. What is the ammeter resistance? What is the ammeter resistance? So the formula will be G S by G plus S. No, for ammeter resistance to be zero, what is the basic condition you can put it? The shunt should be zero. If S equal to 0 ohm, then no current will flow through the galvanometer. No, practically is it possible to construct an ammeter with zero internal resistance? If S equal to 0, then whatever the current weapon will pass through this shunt only, because this will become a zero resistance path. No current will flow, so no current, no deflection. So therefore, what is the resistance of ideal internal resistance of? There's a internal resistance of, I just say ammeter. Ammeter means understood practical. Now, internal resistance of ideal ammeter. Internal resistance of ideal ammeter is 0. So therefore, whenever you get a problem, is it ideal or practical? If I just say ammeter means you're telling it to be practical. Is it ideal if I mention, then where all ammeter is there, you can put short circuit. But here I wrote nearby ammeter 1 ohm. What do you mean by that? So when you are doing a problem, just replace in place of ammeter with 1 ohm resistance. R2, R1, and this is RA. How much? 1 ohm. And carry on the problem. Then what about the reading of ammeter? The current through the internal resistance of ammeter will be the reading of ammeter. So by writing this, so what is this now? I dash. The current flowing will be different because the resistance got added up. So I dash equal to E by R1 plus R2 plus RE. 2 by, this will be 6. 1 by 3 or 0.33 ampere. Coil, the resistance of coil, all other leading things will happen will become galvanometer. Yeah. Galvanometer means nothing but like coil suspended between magnet here. The coil and other many things that will make the internal resistance of galvanometer. Okay, now I got what was the expected value? 0.4. No, this was the theoretical. This is the practical. No. No. So is there any error? Yes, there's error. No. So what is the error? 0.33 minus 0.4. There's the error. So tell me like what is the problem now? Here afterwards, whenever, what is the purpose of ammeter? Why we brought ammeter? To measure current. The very measuring instrument itself will introduce error. So what is the error now? So the error will be percentage error will calculate. Percentage error in measurement of current. How much it should be equal to? I minus I dash by I into 100%. Into 100 you make it. Then you get the percentage error in measurement of current. So you calculate this. The error will be something you can see like it's large, that one. So tell me how to minimize this error. The only alternative available is I should pick up an ammeter of very low resistance. Very low resistance means there should be certain very systematic the idea of that. What do you mean by low resistance? Look at the what is the circuit, what is the branch resistance? 2 ohm plus 3 ohm, 5 ohm, no? The branch resistance. What is the internal resistance of ammeter? Connected is 1 ohm. There's an assumption. The ammeter I picked up whose internal resistance is 1 ohm. It's a given. I can pick up anything. I just picked up an example. You just go to the open in the lab cupboard. You will get ammeters of different range and also the different internal resistance. I just picked up one. And now look at this. There's a practical, no? So what is the problem now? The error is there. How to minimize error? If the value of RA is as low as possible, how much of low? There should be some any specific rule. So if the resistance of the ammeter in a branch in which you are connecting, if the resistance of ammeter is at least it should be 1/10 of the branch, then the error will be minimum. We need not to bother. Of course, there will be error, but that error will become very small. Suppose what is the branch resistance? 2 ohm plus 3 ohm, 5 ohm. Then what is the expected value of the ammeter resistance? Should be 1/10 of the branch resistance. So 5 by 10, 0.5. If the ammeter resistance was 0.5, then what happened? Practically, yes, we can see, okay, even that error comes also, we can manage it. So what is the basic rule now? An ammeter whose internal resistance will become 1/10 of the branch resistance. Then it is said to be good ammeter. Now here if I come with an ammeter of 0.1 ohm, instead of RA 1 ohm, I'll connect ammeter with internal resistance 0.1 ohm. Then definitely you can say it's a good ammeter. Okay, got this now? So the ammeter is said to be good or bad, not with respect to himself, by comparing with the branch resistance. So what is the generalized rule now? the ammeter resistance, the ammeter internal resistance of ammeter must be 1/10 of branch resistance in which it is connected, not total circuit, the branch, that particular branch. And how we have to connect ammeter? It should be connected in series. Are you seeing that one? I want to measure current in this branch. So I should connect that ammeter in series in that branch. So what I should do? I should cut this wire. Then I should connect the ammeter across that wire. Clear this? So here, usually it will be done like this. I'm going to cut it. I'm going to cut at these 2 points. I'll cut the wire here. Then I'll introduce the ammeter. It should be connected in series. So what is the first rule? The first rule, what it says, like the internal resistance of ammeter must be 1/10 of branch resistance in which it is connected to minimize error. Okay, just when you enter into the lab, whichever ammeter, you just go to the cupboard and whichever ammeter you feel, just pick up and connect in the circuit. No. You should first have a basic idea of circuit. The branch in which you are connecting ammeter, what is the resistance? 5 ohm. Then you have to look at the internal resistance of ammeter. If it is around 0.4, 0.4, 0.2 or 0.3 or even 0.5, yes, you can use. If the internal resistance of ammeter is 1 ohm, 2 ohm, 10 ohm, then you should not use that one. If you use, error will be more. Then, so next again, what is the next rule? The ammeter must be connected in series in that branch. In the branch in which current has to be measured. Okay, fine. So this is the some generalized things about the ammeter, that one. So internal resistance, ideal ammeter internal resistance will be 0. So now what is your entire problem solving? What is the problem with the galvanometer? Construction of galvanometer with high currents means I cannot construct a galvanometer which can measure current of 1 ampere. There's a limit. So usually galvanometers, no, maximum is 100 milliampere. That was the maximum possible. So as you go for IG value large, 1 ampere, 10 ampere, no, the size of galvanometer will increase. The magnets which I'm going to put, the coil, everything, no, the size will increase. The cost will increase. So now, what is the idea is practically, if you take galvanometer of range, say like a 1 milliampere, it will cost you say around 100 rupees. 10 milliampere, the cost will become usually around 300 rupees. If you go for 100 milliampere, the cost will come easily around 1200. As the range increases, the cost will increase, even the size increases. Okay, clear this for now. So now I want to measure 100 milliampere. Shall I purchase a galvanometer of 1200 rupees? I'll measure the current, or I'll take galvanometer of 1 milliampere. Then what I do, I'll connect one resistance in parallel. So IG into G. So galvanometer resistance also proportionally will increase. So IG into G. So I'll use this formula, no? So I want to measure 100 milliampere. As you can use this galvanometer. Cost is how much? 1200 rupees. The size also will be very big. Instead, can I use the same 100 rupees galvanometer to measure that 100 milliampere current? Yes, for that, what I should do? I should just calculate the value of S. What is the resistance value? Maximum 2 rupees will come, or very good resistor 5 rupees accuracy. So how much of money I saved? 1100. So construction of galvanometer with very high galvanometer current, what happens? The cost and size will increase, and also the maintenance problem. The error will be more. That's why usually we don't get even 100 milliampere. Usually 10 is the most upper limit. is what I have seen. 100 milliampere is used in some application, but a lot of problems will be there. So in the lab, no, usually you come across 10, 1 milliampere or even microampere. So there's a major problem with the galvanometer. We can't directly increase the Ig value. That's why we are going for alternative. You see, this is much idea, no? By adding another 5 rupees to your 100 rupees investment, you are able to measure large current. Here, what you should do, you should invest 1200 rupees. Got the idea? So this is the cost matters a lot. Even the size also. So this is about the percentage error. So therefore now ammeter what happen? Only ideal emitter no